Hello, everybody. So I'm actually starting early for once. This is exciting. So where are we? So this week is once more into the realm of trying to find some 0 days in real software. And like the past several weeks, we are looking at pdfcrack. So pdfcrack, for those who are joining for the first time, is a piece of software for brute forcing encrypted PDF files. And so for the past several weeks now, we've been looking at it and trying to find a 0 day vulnerability in it and successfully exploit it. And the first week of that was getting AFL set up, going through a whole bunch of the process of doing that, using ASAN. The second week was taking a look at all the crashes we had and starting exploitation of it. We then did a week of exploitation, and that's where we are now. So the current status is we are able to do a heap overflow of a specific object. We've done some grooming using a few different types. So basically, we're doing some heap grooming using the arguments to invoke the program. Let's close this chat for a little while. We're doing some heap grooming using the arguments to the application, which admittedly is pretty much cheating. It means that whatever exploit we come up with is very much non-viable from a security perspective. Like, there's no possible way that I can think of that someone would be able to use this to take advantage of the situation, or any situation, really. Hello, Agenda. With no further ado, let's get into it a little bit. Let's take a look at where we're at. So we have pdfcrack, which is the software we're running. If we load this up in the GDBs. Actually, let's take a look here. So if I remember correctly, args, so these are the arguments that we're passing into it. We're going to take pdfcrack and ls-latr. Input.sav, I believe, is the one that we want to actually overflow that. I believe. That looks plausible. I will buy that that's a real thing. And this in particular was our attempt at... So, where should we go here? Let's go take a look at the source code a little bit. Why? I always forget the right way to do this. So for people who are not used to using screen, by default, screen will... Actually, give me a second here. I'm going to make the video disappear. I'll be right back. I know you can still hear me. Okay. There we go. I was once again shutting things off to make the disk thrashing a little bit better. There's a little bit of latency problems if I'm doing swap while I've got some other stuff running, so I got rid of that and we should be better now. But screen by default, when you open a new window, will do so at the directory that screen itself was started at. And I can do... Screen cannot access your... Okay. I thought there was a very easy way to do this. Yeah, I just want to change directory. So I use screen to do this, basically to make my terminal emulator do a little bit more of what I want it to do. as far as like windowing and things like that, as well as to stay there if I close the window. But fortunately, I don't remember how to do this properly. Nope. Change dir. Oh, that looked close. Sorry about this. Change dir slash home menu PDF stuff. Oh, there we go. And then we want pdfcrack -0.16. There we go. 1, 0. So if we take a look at this, we can overwrite the oh man, I left all these swap files open. I don't know. So a number of people prefer tmux to screen. I think it comes down to preference for the most part. I'm familiar with screen and I'm used to using all the shortcuts. So I don't know is the right answer. I know a lot of people who greatly prefer tmux to screen. I don't really have that much of an opinion over it about it, except that I already know how to use screen for the most part, except obviously fumbling around here trying to remember how to do things, but, you know, you take some, you lose some, something like that. But, where were we? So we're overwriting with using these command line arguments to bash an object, and because of how we've done our little bit of heap grooming using those arguments, the object we're bashing here is this E object. And this E object is the encrypted data like state stuff. The problem is that it is encrypted, or it's bashed after it's been loaded with everything. So what that means is, if we do pdfcrack set args at args, we run it, basically what's happening here is we're not actually getting anywhere. We did successfully bash the object, and if we do a break main.c line, where are we? Let's do 268. We can see that, is this where I want to do this? No, it probably makes sense to do a little bit farther down when it's actually going to load the arguments to init pdfcrack. So if we do it there, we'll have that E object loaded up. We can actually get the proper place, know where we are, and debug it a little bit easier. So pdfcrack main, actually we want just init, oh, but I could init no, it's not init pdfcrack, is it? It is, oh yes it is. Okay, I want cross references to this, specifically the one in main, and they're going to load, it's the first argument we want, so RDI is RBX. So if we break here, 401, 401, oh, X, 401, 45D, continue. So right here, we, that does not do what I think it does. Our BX is a heap allocation that's been made, which is that E object. We can see here, we have overwritten all of the pointers in it with 40180. And basically all that was a pointer we picked that was in readable but non-writable memory. So it's probably like a function pointer or something, if I remember correctly. Oh, today helps if I type properly. Yeah, it's a call to main. So clearly we can't write to main. So if the application ever tried to write to this, we would crash immediately. We get a segfault. However, the segfault we're getting is a call to 0. And that was one of the other crashes we got. So hopefully we can track down exactly what's happening here. And by walking through what's happening, make this not happen. And then later on, it's going to write to one of these function pointers. And we'll be able to use that write to a function pointer to our advantage, is at least the theory that we're going off here. So let's step through this a little bit. So init pdfcrack comes in here. It has the E object. We have enc data, which is, I guess they want a local pointer to it also. But we come in here. Oh, let's continue. So we're in run crack, and specifically the run crack rev 3 is where we are trying, or that's where we're crashing. And we're crashing because, let's open another one of these two. So where is this? pdfcrack line 418. Vim pdfcrack.c line 418. Ah, what? Oh, does that not work in this version? Let's read only this one. So that is calling MD50. MD50 is this, basically it's a wrapper around a function pointer where they've set it up and it should work. The problem is that MD50, or the MD50 init never got called. So grep MD550 init, where is that supposed to get called? So that is supposed to get called from pfcrack 634. Okay. 634. And that should be called, if everything was working properly, from init pdfcrack. Interesting. How does this happen? Only we're fine here. So somehow run crack rev 3 is getting called. But I suspect what's happening is that it thinks we're in revision. Oh, that's what's happening. So, where are we here? So line 556. So if revision is equal to 5, we're going to do stuff. If it is less than 5, we'll do other stuff. If it is equal to 5, we will do some stuff. Otherwise, if it is work with user and not known password, we'll do some stuff. And we'll go through all of this. And eventually, it will default to revision 3. So clearly what's happening here is we're defaulting to revision 3, but because we've bashed the object that tells it if it should initialize that or not, it never bothered to initialize it. So we're good. When we ended the stream last week, there was a little bit of a question, at least to me. Some of you might have looked ahead and taken a look at this software on your own. But there's a question in my mind. Oh, I hit caps lock. There we go. Yeah, that's one of the more annoying typos to run into in Vim. If you hit caps lock when you use J and K to move around, you're doing Shift J and K, the capital J and K, which is combining with, well, capital K is searching for the man entry for stuff. Capital J is combining lines, which unfortunately is very rarely what I actually want. So, what do we have here? So because we're bashing revision, we would come in here. We would eventually init passwords. What happens here? So right now, I think the best idea is let's walk through this manually and take a look at things and hopefully figure things out. So we have CS. CS is getting passed in. And CS is car set which came from... So that's where it's getting passed in. Okay. So car set is an argument, but I thought we could specify car set as when we loaded our thing. Well, in any case, car set is a local pointer. It's not one of the ones out of E, so it's not quite as interesting. It's not one of the ones that we would be able to control. So ideally what we're looking for here, right, is I'm going through the source code, and I'm hopefully going to find a place in here where we're able to actually take advantage of this and what I'm looking for. Hopefully get a arbitrary write out of it, where we're able to take one of the pointers in E that we've overwritten and actually trigger something useful with it. But it doesn't look like, at least in this part, that it's going to do anything useful. We do have this MD50 in it, which might be interesting. So, oh, that's not what I wanted. If the length is 16, we can control which variant we use. I don't think that's going to be super useful, but we should keep it in mind. We can set the RC4 decryption method. Well, that looks bad. It looks like it has to be less than that. It's an unsigned int. That, yeah, that doesn't look like it's anything useful. If UPW, we will take a stir line of it. We will memcopy to password user the UPW. Where is password user? What is password user? So UPWLen is the length of a password. Oh, well, I guess it does terminate here, so that's not super interesting. Although, what is this thing? So it is 40 characters. Wait a minute. It's 40 characters. They'll copy 32 in. Then they will they'll pad it. What does memcopy of 0 do? cd-pdf vim test.c io.h. What is the VO at line 656? I do not see what you're referring to. Unless that was on one of the other screens. Car A. Sure, let's give it some bytes here. And I want to memcopy a est 0. So what I expect to see here yeah. Oh. Helps if I actually do something with it, doesn't it? Comma A. It's not doing anything. It might have just been like some buffered stuff that I wasn't setting up properly, or that like, because for whatever reason my windowing is a little bit messed up right now. Like I'm missing a bottom line here, which is unfortunate, and I'm not sure why. But so we did that. We will copy, pad it, and we set that up, which for the most part seems fine. UPWLen tag not found. Oh, it is an unsigned int. Okay. If we're in recovery, we'll copy that in. That's fine. None of these seem particularly dangerous because ink key workspace is this global. Although I didn't realize that it was a where did that get set up? Ink key workspace. Oh, it probably gets initialized in here, doesn't it? Yeah, so they malloc it in here. Well, no, so we don't actually control that. So we control one of the two sizes for it. None of these seem particularly interesting, right? Those conditions are the same, so that's not an out of bounds right. Wait, what? So we'll allocate 68 bytes up there for it. And we'll still copy extra bytes into it? That doesn't look right at all. Why would you, what are you doing? That's bizarre, because that is clearly wrong. But unfortunately, not wrong in a way we can take advantage of. Like we get another heap overflow is the best case scenario we get out of this. And I don't know what that gets us anything useful. So this is a, yeah, like this is clearly a heap overflow. Okay. I guess there's another one in there, which I guess isn't that surprising. Given what we've seen in this code, like I'm not super surprised that there are places where there are problems. So here, this is one of the pointers we can modify. And what happens here? This is just, where's buff coming from? Where is buff coming from? So buff is, oh, buff is a stack variable that we control the size we're going to copy into. Oh. Well then, huh. This might be much faster than I thought it was going to be. So what do we need to do to get down this path? So we need to first not be version 5 or above. We need to pass the set RC4 decrypt method. We need the version to be 3 or greater. And then if we control these two things, we will get to what we want. So we have an E, which is actually P. I can never remember the right shortcut to go forward on the stack. So E is an enc data. What? Oh, yeah. I want an enc data. An enc data is this thing. So we want to overwrite file ID and file ID len. We want file ID to point at stuff we control. We want file ID len to point at, or we want it to be a large value. And we want everything else to be junk. Except for version. Version should be 3. I think we can do that. That's a little small, isn't it? Run this. We'll go to here. BX, RBX. So, actually, struct enc data star Okay, so you want to actually decode it for me. I thought there was a way to get GDB to decode that. Do this? Yeah, it did do that. Okay. So we want to point file ID at data we control. We want to point everything else should be fine, but we need to make sure revision is 3. Is there some place in the data section right now that would have data we control? So when we do the workspace setup, what are we going to do? We're going to copy so owner key will be there, which is 32 bytes. Well, so it's not a custom struct, although you can do that too. So because I compiled this myself, we didn't strip the symbols out. So GDB can look at this, it sees all the dwarf debugging stuff, and when I do struct enc data, it knows that, like it looks up and it already knows what that structure looks like. There are ways to add structures to GDB. I just don't know what they are off the top of my head. I know you can like write an .h file and give it to it. You can also write Python to tell GDB how to process something. Both of those work. They've never been useful enough to me to do it because looking it up and then doing it is always longer than just writing, a few lines and copy and pasting over and over again to do it myself. So, but yeah, it's probably something worth looking up at some point and getting a better hang of how to do it. So as far as this goes, enc workspace is not something we control because it's malloc, so this isn't useful. Wait, why don't we do this the other way too? I should be able to come in and say that I just want a pointer to your data section. Okay, iproc mappings 20gx. This guy? I think it should be this guy. That looks like a BSS to me. Don't care about most of this stuff. It's interesting that handler there looks like ASCII. That doesn't look right at all. Yeah, okay. So what I was really hoping for was that we had some path through here that, so hopefully what we can do is we can get it set up so that someplace in the data section here, we have data we control. And if we do, so the problem is that the stuff that we're overflowing, that we're writing into directly, is all on the heap. So even though it looks like we can just smash the, I'm sorry, I'm blanking here for a second. We can smash the stack with data from a pointer. We control the pointer that it's coming from and the length of it. We need to find out where data we control is in order to do that. There's a few different ways we can do that. Most of them are kind of gross. But there might be a way to cheat a little bit. If we remember, most of these pointers are being set up because they're being allocated. So we want forward, when we come in here and we do recovery, we open, when we load state, how do you get set up? Well, let's start with this one here for a second. So it will take file ID len of 256 up to 256. Doot. Let's make that go away. So it'll take up to 256 bytes, copy them onto the stack. That sounds good. Right? Especially, it's gonna... Is there just a trivial stack smash in this thing? Why didn't we find that if that was the case? Come on. Where are we? Let's make a new one. Copy input.sav. Let's do base.sav to stack smash.sav. So if I'm reading this correctly, we're going to read this line right here. So PDF, the major version, the minor version, the revision, we want the revision to be 3. Agenda is asking if jumping to definition is standard Vim stuff. It is, with a big caveat. So the big caveat is you need this tags file. So the directory, when you're using Vim, it will check the current directory that you're opening Vim for this tags file. And if that tags file is there, you're able to use it to jump to definition. It's control curly brace, the one on the right side, that one, to jump to definition. And to generate the tags file, the easiest way to do it is ctags-r dot in the directory you're going to open everything from. And what that does is that uses, I don't remember how ctags actually works, but it basically parses a whole bunch of C files. And it creates that tags file for you. And that way you're able to jump to definitions for stuff. So that's what that is. So where were we here? So we read in the revision number, which is 3. That's good. The V, which is version, which I don't think we care about. Permissions, which, again, I don't think we care about. Length, which seems fine. Then metadata, which is going to temp, and file ID len. Okay. All of this seems fine. So if file ID is 256, and we want assume, yeah, it's going to read in a character at a time. So Python, we want to, what's the best way to do this? Print 41 space times 256. Yank. There we go. So that should, if I'm reading all of this correctly, just basically be a trivial stack smash, right? And we have a D here. We do have a D here. So where did we say this trivial stack smash was? Init pdfcrack. When we do this right here, if it is greater than or equal to 3, we're going to come down here. This is pdfcrack.c. So b pdfcrack.c line 664. Like, I'm really surprised right now that AFL never found that. Yes? No, this is not doing what I want it to do. Set args -l pdf or ss.sav. That is for, by the way, that is for stack smash, by the way. That's why we're calling it that. We have our file ID that we read in. We're now at the first of these mem copies. So we're setting up the first mem copy. Wait, what are we doing here? Are we not quite where I thought we were? Oh, we're still in main. Oh, that's interesting. Oh, no. We're where I thought we should be. So we're at the first mem copy. We're going to, yeah, we're gonna disp/I rip. Let's go right up to that call. So, RSI is the source. Oh, because I did 4 ones, which is decimal. I guess that's fine. It's going to, yeah, it's going to straight up copy 256 of those onto the stack. Locals at unknown address. I want iframe 1. Yeah, like this is totally going to. Huh. I'm really surprised we did not find this earlier. Like, I am honestly shocked that AFL never found this. Because there's just a trivial stack smash there. Wow. That is kind of incredible to me. Huh. So, we have that going for us, I guess. I guess it's good that we were going through this because we found that. So, the downside here, one thing that's pretty important is that we can't really use this. At least not with the way we've got things compiled right now. So, depending on how we feel, we can cheat some more, and we can say, you know what, we're just going to turn off the stack protector. Because if we don't do that, we're in a little bit of a pickle, right? If we don't turn off the stack protector, we're just going to get a abort here from the mem copy. So what's happening here is the mem copy is checking to make sure that we don't bash stuff. And we can pass the compilation flag to it to turn that off, which is one option. Or we can keep going with our heap overflow. So let's do the first part of this, right? I want to copy pdfcrack to pdfcrack normal. And I want to edit my makefile. What is the flag for this? F no stack protector. No stack protector. Am I spelling that correctly? I am in fact spelling that correctly. Look at that. Dash F no stack protector. Make. GDB is roughly equivalent to WinDebug. WinDebug is probably better. It has a lot more functionality for, like, it's a lot more fully functional. But as far as debugging on Linux goes, GDB is about all there is. There's a couple other things like DDD, but GDB is about it. And let's run this again. Set args-l-ss.sav. Continue. Run. But I compiled you with... Pass in f no stack protector. What? Now I'm confused. Why are we still getting this? Let us Google this real quick. So how do I turn this off? Yeah, so it's clearly using... we're going to open up a new version of this because we have the new thing. Go to that. DCC, don't use memcopy check. Come on, Google. DCC flags. So what we're looking here is the flag to turn off the checking, whatever that is. If anybody happens to know what that is off the top of their head, that'd be awesome, by the way. I assume it's one of the flags you pass to a lot of stuff for building CTF binaries. Oh, there's a dash all. Look at that. I actually don't know if this is what I need or not. Make. Ah. Or not. Hey. No, that can't be. I mean, yeah, see, the problem isn't that the stack is not executable. It's that for whatever reason, it's still like even with the -f no stack protector, it's still using the mem copy with a check, which is not what we want. Disable mem copy check. If I want to spell it correctly. Disable use. Yes, I want something like this. Let's try this. Ow. Stop it. See, when I plugged in all of my cables, I forgot that one. Do 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 do. What is mud flap? Never heard of that flag. Yeah, sure. Why? Like, I'm setting that flag, right? we're setting it to 0. I'm really confused about why this is happening. Large file, f no stack detector, fortify source equals 0. Oh. I'm being dumb is the problem. I was getting rid of the binary, but not all the pre-linked pieces of it. Ta-da! So, what do we have here? I assume that if we go back and we do... yeah, let's just run this in GDB. So, set args. We're at the ret. And look, we have a thingy. Look at that. How wonderful. So let's go about actually writing an exploit for this thing, right? So let's write exploit.py. We want to have, what do we want to have here? So let's take, oh, we already have this thing open. Where is this thing open? Here we go. So let us get rid of that, %s. Yeah, that should be good. So I'm using pwn tools here just because it is so easy to do a lot of things. I'm not sure if we're actually going to need it or not, but I find it really easy to use. I'm used to using it for CTF stuff, so we're going to use it here. So file, open ss.save. We then want to build our buffer. So machine, we'll just call it that, is equal to cyclic. So input, so what we're actually going to put in there is going to be, what's the best way to build this? There's trying to think of the best way to do this. So we could build this in a list comprehension, which is one way to do it. Or I can write a for loop. Let's do the for loop because that's going to be easier for people to read. So for byte in chain, we want this to be 256 bytes. Input plus equals %d space % ord byte. And then out is buff input, open test.sav. We then want to do s is equal to process pdfcrack -l test.sav, and we need to pass the shell is equal to true argument because we're giving a command line like this, not a argv. And then we'll just do s.interactive. We should see when we run this now is a typo because I apparently can't write Python. No such dot write buff. There we go. What is this? Oh. Okay. One more time. Ooh, we crashed this time. That's interesting. Why did we crash? We got the right file ID. Oh, there we go. Yeah, we got a core dump. Yeah, we got a core dump. Okay. GDB pdfcrack 4. And if we go x/gx rsp, we have that right there. So this tells us where we are in our file. Cyclic 256.index NAAB. So what we're doing here is Pwn Tools has cyclic built into it, which is just generating a string which any substring is globally unique. So basically, over a certain size. So because I know that NAAB is out of that string, by just indexing into it, I know exactly where it was. So I want to do 152 chain plus equals ROP. So we have, what does that math look like it is? So 156 bytes is the input, or 152. So we have another 100 bytes of ROP chain we can have. Okay. Dash dash binary, pdfcrack. Am I going to be lucky here? Cannot open. How do we end up here? Oh. ROP gadget binary. Yeah, the cyclic stuff is very common. The stuff in... Oh no, we don't have the right gadgets. That's unfortunate. I was hoping we'd be... So there's the ROP chain flag to ROP gadget, which if it can, it will auto-generate an entire ROP chain for you. But it's pretty naive. So it looks like we weren't lucky enough that we just have a single ROP chain that just works and gives us shell. Which means we're going to have to do this the hard way. By the hard way, I mean actually have to write a little bit of code. So what gadgets do we have? Into gadgets. We come back over here. Yeah. What do our registers look like? So we control RBX, RCX, and RBP. And oh, we also control R8 and R9. Oh, we control basically everything, don't we? Yeah, it looks like we control almost everything in this entire thing. So RDX. Okay. And what does RSI look like? I don't know what those two pointers are. Those are both heap pointers, but we don't know exactly what those are. So unfortunately, we don't have anything really great here. Like, ideally, we would have at this point like just some magic gadget that just pops shell for us, but it doesn't look like we can do that. Do we have... We go back in here. Do we have something in the data section now? So what I'm hoping for is that we will see some ASCII in here. That is something we control. Password user looks good. So 120 this is 78. What I was hoping for was that we'd be able to just specify there what it was, but it looks like that doesn't quite work out as easily as I hoped it would. This is a heap pointer. Print slash x72. That's a 48. None of those look like inputs from our file, which is unfortunate. If they're inputs from our file, we'd be in much better shape. And what does this thing look like? That's a pointer to a pointer, so I don't want to do that if I can avoid it. That will eventually be something useful. So we could do something there and maybe get to it. So what I'm hoping for here is that we can find something easy. Are we lucky enough that we can just say no? What I was hoping here is that we could just go, oh look, system, any read or video that will help me understand what I'm doing. Federico, I'm not sure. There's a few different books on exploitation that I've seen recommended over the years. I know it's probably quite dated at this point, but The Art of Exploitation in that green book with the shiny cover is the way that a lot of people I know read about things like this. But realistically, I think the best way to do it is just to try it and see where you get to. There's lots of write-ups for CTF stuff and war games. So basically go out, try some of the easy stuff, probably fail at it pretty hard, but learn as you go and keep building up until you really know what you're doing. That's what I would recommend doing. Basically, just go through, know that you're going to completely fail at it a lot, but be okay with that and move on. That's what I would recommend, at least. So, we don't have system, which means we're going to have to do some actual work here. What I was hoping for was that the binary would import system for some reason. It does not. So our ROP chain needs to do at least somewhat real work. And according to ROP gadget, it doesn't have the gadgets we need. Oh, right. I should actually finish dumping all this out, shouldn't I? We had car set. We didn't load anything into that. Word list we did load, and if we're willing to cheat a little bit more, we can control the stuff at that. Oh yeah, Corlan is pretty great. That Nick recommended. It's a set of tutorials. Again, they're pretty dated, and they're for Windows exploitation as opposed to Linux exploitation. But they're really good, and they're really good to learn about what's going on. So, okay. Well, unfortunately, none of these jump out at me as being the most amazing. Like, none of these pointers seem super useful. And unfortunately, none of the, at least according to ROP Gadget, it doesn't have some of the gadgets it wants to have. So, wow. Not a great set of gadgets. Jeez. What is going on here? Oh. Yet again, I have caps lock turned on by accident. Wow, that is a very awkward set of gadgets. So there actually are no... Wow. These are awful gadgets. I was hoping for was that I'd be able to just, like, dump into a register. One of the things that ROP Gadget does when it's pretty naive about how it generates that automatic ROP chain. So sometimes you're able to, like, push it along the way. Wow, these gadgets are not great at all. Like, half the gadgets are different types of rets. What ads? We have like a... So we have add byte. That doesn't look awful. If we can load CL, that's not too bad. Like if we can load CL and AL reasonably well, we can write a byte at a time. I can live with that. Do we have a add? We do not have an add quad word, which is what I was really hoping for. So if we had an add quad word, we could do this like in one shot real quick. But it looks like that's not going to be quite that easy. What do we have here? So we have an add EDI to RCX. Or we don't want to return far. Those are hard. I think our man, a lot of these are a little awkward. Because we don't want to do a return far. If we do the RDI RCX1, as long as RDX points at valid memory, and if as long as RAX and RDX point at valid memory, I think we're okay. Valid writable memory. That's not awful. We can do that one. What do our pops look like? So we do not have a pop RAX. We control it to start with? It's 1. Well, I guess that doesn't work very well. Is there a move RAX we can take advantage of? Right, there's no pop RAX at all. How about a move here? I mean, I guess we could load it that way, which wouldn't be awful. Move EAX, EDX would work. Can we load EDX? We can, but it costs us a lot to do so. Oh, but we start with RDX, don't we? No, but what is RDX? That's fine. We could live with them messing with that. Like, it's a heap pointer, but we're not going to care about it getting smashed, I don't think. So what was this gadget again? You were doing an add RDI ECX. Is there an ink RDI? That'd be great. Not an ink RDI. Is there an add RDI? Is there an add DI? I could live with that. No. Add. There's not an add RDI. Well, this is awkward. I was really hoping this would be easier than it's turning out to be. At this point, we have the start of code execution. We need to turn this into something useful. Like we have 104 bytes of ROP chain we can use. So how are we going to do that? Because these gadgets are honestly kind of awful. Like, I'm really surprised at how bad a lot of these are. Especially since we didn't, like, compile it with any weird flags. Part of the problem, isn't it? Oh, it's being compiled with 03, which I guess is... Yeah, we're not going to mess with that too much. That seems like a little bit too much cheating. So if you mess with the optimization levels, you can frequently get different gadgets. Well, you will always get different gadgets, but sometimes you can get to stuff you actually want to be able to write to, as opposed to junk. Oh, what an XOR. Very useful XOR. That isn't going to cause a lot of work. So there's an XOR byte. Ideally, I want to do an XOR of like... What I'm really looking for here, and what I'd like to have, is something that lets me write a quad word at a time, so I have to do less work. None of these will do that. None of the rets will, of course. They're like a... RSP stuff. No, we don't want to point what I was thinking here is maybe we could like point RSP at something and push stuff. But that seems, I don't think we have the right setup for that. So again, this gadget will work. Where's the gadget we were talking about using? There is an add. It now. I thought it was this one, but we don't want to deal with it right far. Oh, it was an add D word. That's even better. I can live with an add D word, right? I could live with these. I think I could live with most of these. That seems not awful. But we don't have a good way to increment DI, do we? But we can pop it, can't we? We have a pop. Yeah, we have a pop RDI. So we can definitely do that, right? So let's do that real quick. So we have our add D word RDI. We want yank those two lines. Or we were writing this. So our ROP to P64. We're going to leave this as a comment here. OX407 AF7. So we need to load RDI and RCX with stuff we care about. And we need to make RAX point at stuff we don't care about. And we said that... No, stop that. We talked about this on Monday, that I don't think I have ever typed F1 and actually wanted help when I'm in my terminal. Well, I mean, I want help, but not the help file. So move RAX, move EAX. Move EAX. Yeah, so I would say one of these would work. I guess this works. It does lose us a lot of gadgets. So we will do this thing. ROP plus equals P64 405761. So we're loading EAX with EDX, which is fine. That's a writable pointer that we can, we can write to it, which is good enough. All we care is that those exchanges don't cause us to crash, that they point to something useless-ish. Then we're going to pop two values. So ROP is plus equal to B times 8 times 2. We're going to load RBP and R12 with Bs. We then are going to, we need to load RDI and RCX. So pop RDI. There's a pop RDI. Is there a pop RCX RBI? Because that'd be perfect. Oh, there's no pop RCX. Oh no. Ooh, we can't load RCX, can we? Sure. So they were asked, Agenda is asking in the chat if I can describe what we're doing here. So what we're doing here is we're trying to build a ROP chain, which is basically, so the place we're currently at is we have a simple stack smash that while we were going through we found that is letting us get code execution. We can point the instruction pointer anywhere in the application that we want. However, on almost all modern systems, we're going to have what's called NX or WAX or what are the other names for it? There's a couple other names for it, but the short version is that for code segments, you will rarely, if ever, be able to both write to them and execute them. So for any given address, you can either write to it or execute it, not both. And there are some exceptions you can go through to get it set up, but by default, that's the way all modern systems are. So we want to run code we control because there's not some place in the binary we can just point it at that will give us whatever it is we want. At least in theory, there isn't. Well, in practice, there almost never is. So what we're doing here is we're trying to take little pieces of the binary and run them one at a time. And if we chain them all together properly, we should be able to get whatever we want out of it. And the first piece of that is the ability to write into memory. So right now, we have 100 bytes of this ROP chain that we can execute. However, we want more than that because we need to. So what I'm trying to do here is I just want to call system bin sh. If I can do that, that's good enough. We can live with that. But I don't see an easy way to do that because what did we say here? Did we say that any of these things were things we could control? I don't think any of the, because we need to be able to pass a pointer to /bin sh. There's not one of those in the binary, is there? Probably should have checked that earlier before I was trying to do this. Bin? Yeah. Okay. Because we want it in a, if it's on the heap, we don't know where the heap is. If it's in the data section, we do know where that is because we didn't set it up as a pi binary. So let's scan through that again real quick. iproc mappings 60D12. So password user would work. Whatever password user is. What is password user? I want an S here. So when I saw these 2E, 2E here, I thought that that might be something real, but it looks like it is not, in fact, real. I suspect what that is that's one of the MD5s. And if it is, we can technically control it, but that's going to be really messy to try and make arbitrary values. None of the rest of this stuff does what we want. What are these? It doesn't matter. Like, at this point, we're in the heap, right? 6.0, yeah, we're in 6.0e, so we're already in the heap now. And we don't, do we have a good way to move? Gadgets are really limited. Wow. I guess it's what dash R3 gets you, or the O3, the highest levels optimization is going to get you. It, man, these gadgets are not particularly nice. I don't think they're doing this intentionally. Like, I highly doubt the compilation is done with respect to, like, intentionally trying to get rid of all the gadgets. But there are very few useful gadgets in here. So let's talk about what exactly we're trying to do here. Ideally, what I want to do is I want to set up a syscall. Is there a syscall? There's not a syscall. Oh. Well, so an alternative here, which I'm much less of a fan of, is we can read out, we could write a ROP chain, which is going to take a value out of the GOT and add an offset to it, which will work, but it means that our exploit is now non-portable. If we could somehow get things set up such that we didn't have to do that, that'd be very advantageous, because by reading out of the GOT, so that's the table, the global offset table, it's the table in memory to tell the binary where the functions it wants to call in libc are. Well, not necessarily libc, but any library. So we can take a value out of that, we can change it to what we want it to be, and then call that. I'm not a huge fan of doing that, because doing that means that we are highly dependent on what version of libc we're running on. But looking at these gadgets, I'm not convinced we have many other options. So we have an add EBX ESI. So if we, well, not true. We could also use one of these adds directly. We can't load RAX, so that's out of the picture. RBX, we can, but the rest of that gadget is bad. We can't load ECX at all, which is awful. What these add bytes? Were there some of these that were useful? The problem with using an add byte is under the situation where there's overflow, we will fail. But will there be overflow? Or will overflow be predictable? No, maybe. It might introduce a 1 in 256 chance of failure, I think. Are any of these useful? So remembering that RAX we can't load. RCX we can't load. So none of these are useful either. Makes me unhappy. We have so many bad gadgets. Wow. So we don't have any way to write. Wow, these are pretty awful. So what functions do we have again? Like, can we do something a little simpler? So we have puts, so we could print random stuff, but we don't care about that. Set up an alarm. We can. None of these functions seem particularly useful either. This is unfortunate. So one thing we could do is we could write to man, this is really awkward. Gadgets we have are super awkward here. We start controlling RCX. And we control RBP. So we can There's not an equivalent pop that we can use. So we can use this gadget to read an arbitrary address onto the stack. So we can push the got entry onto the stack. We can pop it into a register. How do we add to that register? An easy way to add to that. All of our ads are awful, aren't they? Add constants. And that's it? Is that really it? Wow. Are there subs? Maybe we can use a sub? Our subs aren't much better, are they? Subs are worse. No, they're not. They're pretty bad. This is really unfortunate. Because just none of these gadgets are very good. We don't have a syscall. Without a gadget with a syscall in it, we're not going to be able to do a direct syscall. Which means we need to do something either with a function that's already being imported, or we're going to have to modify stuff into libc. Which, I mean, I guess if that's the only option we have, that's the only option we have. We're going to have an exploit that will only ever work on my machine. But I can live with that. So what we'll want to do then is we will want to print out a value. And then what? So we need to read a memory. So agenda is asking how I know if a gadget is good or not. And the answer is basically just looking at these and trying to determine, do any of them do what I want to do? And what I want to do right now, so originally what I was hoping to do was to have some simple way to set up the arguments for a syscall and make a syscall. Because then I can just set up a... Okay, so let's start back a little bit earlier. So ROP was the use of snippets, small snippets of a program in a series, because we can't just write our own code. And what those snippets are those are what we call gadgets. So something like this right here. This is a handful of instructions that does a thing and then returns. So because we've smashed the data on the stack, when it goes to do that return, what return does is it pops a value off the stack and then it jumps to that value. So basically, because we control a whole bunch of values in a row on the stack, we're able to chain a whole bunch of these together such that we will exchange EAX, EDX. We'll do this and we'll then add RSP and then we'll pop and then we'll still have control of what's going to execute next. Basically, we're able to chain these gadgets together. So when I say they're bad gadgets, so something like this, a ret with a very large offset, it's useless to us. Because of how large that offset is, it will put us entirely outside of the range we control when that ret happens, and an exchange EDX or EAX EDX on its own isn't very useful. Other things that are more useful, so some of these things like a, I do not want a visual block here. Some of these pops, those are going to be useful because those let us load registers with values we control. But it means we have to find stuff to actually do things useful with them. So what I'm looking for is some way that is going to get me eventual more codecs. Like I want to be able to run things that are not just these little ROP gadgets. I want to run anything I want. And at least in theory, the easiest way to do that is for me to just start a shell somehow. But I'm not even seeing good ways to do that. Was there an exchange down there? Like an exchange to memory? So there's an exchange of AH to memory. But that's not a very good gadget at all, because we can't load AH. Right. So it's a few instructions that end with something that will let us retain control. So return is going to do that pop jump. So because we control the stack, we can still we'll be able to put another gadget after it and still get a chain of them. Alternatively, there are things like a call register. I'm trying to find an example here. So some of these end in a like call RAX. And so this is a gadget because if we control RAX, we'll be able to execute all this and then call something else that we still control. And the idea is that you're able to chain several of these together and eventually get it to do something useful. But look at this selection of gadgets. So we have a total of 772 gadgets. And very few of these seem like things I would actually want to be doing. The add with carry byte is probably the best thing I've seen. But both of those are rets with very large offsets, and that's not what we want at all. The add with carry byte pointer RBX BL is probably the single best gadget for doing something useful that we've seen so far, which is pretty sad because BL is the low 8 bits from RBX, which means basically we can add, like, what we're adding to this is not controllable. Ugh. RAX, we can only load from RDX, which means all of these add bytes RAX are not particularly useful. If they were an add quad word, they might be. Even add D word might be useful. So if we can load it once, we might be okay. But it's... So these are... I ran ROP Gadget, which is a tool by Jonathan Salwan, I believe. Which will go... It will take a binary, and it will parse out all the gadgets that are in it that are useful. And there's a whole bunch of flags you can supply it to do different things, to filter it, do things like that. But I just use it by default options to print all of them out that it was able to find and take a look at them. No, I'm using ROP Gadget, not Redair. There's a whole bunch of different ways to do it. I like ROP Gadget just because it does most of the things I want it to do. Plus, it has the ROP Gadget or ROP Chain flag, which if it can find the gadgets it needs, then it will automatically generate a ROP chain. So, just as an example here, let us do move pdfcrack stack smash, and then make file. We switch to 01. I think usually has the best gadgets. pdfcrack. Make clean. Let's remember to do this properly this time. ROP gadget, binary, pdfcrack. Let's just dump this out to gadgets 01. And if we supply this ROP chain flag, it still can't find the gadget at once. Oh wow, there's even fewer gadgets this way? Huh. What do you know? Huh. But you can see here, like, I can actually load RAX this time. So that's way more useful in terms of things I might want to do. And what if I... so like looking at this list, the gadgets are, well, not completely different. They are quite different. Right. Um, looking at the gadgets I have right now, so there's a number of different ways I could go about doing this. And the easiest way to do it is I find some short chain that's going to get me something useful. Unfortunately, none of these seem to do that. Like none of these seem to get me exactly where I want to be. One of the things I can do, hmm, none of these seem very good. So I apparently have a message on the... Oh, it's responding to some stuff. Um, hmm. Hmm. So the add EBX ESI looks like the most promising thing I've seen. But do I have any way to write to EBX? So one of the options we have here is I could read a value out of the GOT. I could add or subtract from it. And then write it back. I mean, ideally, we would add or subtract from the GOT entry directly, but there aren't any ways to do that except for ECX and... Oh, wait a minute. ECX we control. So we can add dword RDI ECX. And we can pop RDI. Wait a minute here. This might be quite doable. So if we use... Oh no, which gadget was it? Just saw it. I was just talking about this. This gadget. So we can use this gadget. We can only use it once. So when we were looking at this the first time, we were talking about using it to write /binsh into memory. That's not going to work because we're only going to be able to add a constant. What we're going to end up with is basically bad times. Like we would only be able to do it once, but once should be enough. So if we increment this, let's think this through a little bit. So let's say we remap one of these functions in the GOT, and then we call it. That seems good. What are we remapping it to? Where are we? There we are. Oh, quit IR. So RCX we fully control. And RDI we can load from a pop RDI. All we need to do is we need to make RAX writable, which we knew how to do already. So let us add to an arbitrary value. And we're going to be able to add that. So what I'm going to do next, I we are now diverging even farther from this being a security relevant exploit, in that we're going to use the bespoke gadgets. And the bespoke gadgets are basically the idea that there exist in libc single addresses that if you can call them, you will just get a shell. So these are basically magic. The short version is that, and here I will show you in a second how they work, but we did LDD on this, so I want to do one gadget lib x8664 enu libc.so.6. So this is a script that David somebody wrote. You can just Google one gadget David, and I think it comes up. And I'll post links later. What this is doing is this processed my libc and said, if I can call offset 5426A in libc, it will do an execve of binsh with the argv set to rsp plus 30 hex and environment is set as the current environment. So if rsp plus 30 hex points at nulls, we are good. No, it needs to end in nulls. That's fine. We control RSP, so we can totally do that, right? x/gx $RSP. Like, that is a value we entirely control. And we control quite a ways down from that. Actually, we don't control that far down from, but the way the stack is set up, we have plenty of space to spare. So, where were we? Let's come in here. We want our final gadget to be or what we want to do is we want to set up a call to that. Let's make sure that there's not a better one of these to use. 6, 5, 5. IR. No, you reran it. Why did you rerun it? The higher ones are going into data we don't control. RCX, we could potentially make point at nulls, but we need to use that for our add, which makes the rest of those not useful. Okay, I can live with that. So we want the value to eventually be 4526A minus so we want ECX to be, let's start off with what we're going to do here. We want to pick a value in the GOT. Let's say malloc, because why not, right? Whoa, where are we here? Oh, that's in strings. Actually, let's do free if I can find it. We have free here. We have free here, which is at, the GOT entry is at 60E020. So free at GOT is equal to 60E020, which is where we want to write to. So we want RDI to be that. And we're going to do elf libc is equal to elf libc.so. Lib x8664 gnu libc.so.6. .6. And the value in ECX that we want is going to be, so RCX is equal to libc.symbols free So that's what's currently there. And we want it to be OX4526A minus whatever is currently there. Right? That makes sense. So where is cyclic coming from? Or I'm sorry, where is ECX coming from? So we want to take this thing from pwn import star cyclic 256 index E64 that thing 160. So wait, what? Okay. The first gadget. That's weird. So RCX is going to be the second set of D words, or the second quad word in our ROP chain. So what's the best way to do this? Let's go back to our ROP gadgets. So do we have a pop something, pop RDI, ret? We do not. So the other thing we can do is we can just take any of these. So like a pop RBX, that works fine. So yank this. I want ROP. Oh, we don't actually currently have a ROP chain. Plus equals E64 OX407954. ROP plus equals RCX 4D. Put it down here. Right. So we loaded up our libc to know where we want to go in libc. We know that RCX is this magic gadget minus the offset to free. We then say we want to pop RBX, the value that's going into RCX. And the reason for that is because for whatever reason, while we control RCX at the start of a ROP chain, we can't do anything with it. It's because it's coming the second quad word out of the drop chain. So that's what we're doing here. We're setting that up, so that'll work. So now RCX points at what we want. We now need to do a pop RDI. We want to load up RDI with a address that we want. Pop RDI. And we want this one. So ROP plus equals P64 401 OF1. We want to then put P64 this address 60E020, which I already wrote in here. 60E020. So we're going to then pop RDI. So RDI now points at the got entry for free. We're then going to use this big thing, but we need to make sure that both RDX and RAX point at writable memory first. So RDX does, RAX does not. So we need a way to do that too. So move EAX. This will totally work. Right? So EDX and EAX will point at the same thing. And we can come back here and we can replace this gadget with that. So we're going to do two things at once here. 55EE. So we have a pop RBX, which is fine. RBP R12. And I think that should just about work. So ROP plus equals E64. We now need to find a place where they call free. Any place they call free is fine. So 401165. And actually, let's do this. And the reason we're doing it this way is I want to see it crash, basically. So we do this. Oh no. Line 17, I failed that. E64, that right there. There we go. Out of range for Q. What? Oh. It's negative, isn't it? Interesting. Okay. Yeah, it's a negative value. So we want to add OX1, 1, 2, 3, 4, 5, 6, 7, 8. That is 32 bits. 1, 2, 3, 4, 5, 6, 7, 8. Ta-da! Yeah, look at that. It worked, kind of, because it started binsh. No, binsh. No, it did not work. Why did it not work? RM core. Not a save file or save file is damaged. Oh, right. Chain plus equals D times 256 minus the length of chain. Much better. So what was happening here was the program is checking to read in 256 bytes, and I wasn't giving it 256 bytes to read in. Duh. So now we should see. Ooh, no. RDI. Really? That should work. Why doesn't that work? Oh, is my address... Did I typo that? No. Okay, let's try this other way. 401165. D. Oh, it's because I'm looking at a different version of it. So checksec, I just Google it every time I need it. So every time I build a machine, I Google it. There's several different versions of it. GitHub checksec. I think I just use whichever one. Like I open up a couple of these things. Last updated a few weeks ago. This is the one you want to use. So use that. And I've just got a git repo of that I cloned, which should just work, I think. So 40. Where was I? 4118C. I think this should work now, right? We changed what we wanted RDI to be. Wanted the right thing. RM core Python exploit. And that is totally pointing at C's. So if we now do OX60D020, that's not what I wanted to see. That didn't work at all. Oh, we haven't called free yet, have we? So one of the kind of tricks about using the GOT is that before, so the GOT is populated before or when the program is starting up. It's populated with values, but to start with, the values it's populated with are pointers into the binary. They're things like this 400 stuff. So they don't work if we've never called it yet. They still point into the binary. So instead of doing that, so we're going to use E8. This is pointing at stir2L. So we're going to change this from free to stir2L. And we need to change this call to the actual call to this, which is 401047. Let's try this again. RM core, Python exploit. Now we're going in the opposite direction, so we don't need to do this. And well, that's not how that's supposed to work at all. You should have been called. Why weren't you called? Yeah, sure. Let's do malloc then. Just to make things complicated, we're going to keep changing things around and being super confusing. D108. So this is now malloc that we're modifying. And we need to change this to a call to malloc. Where is a call to malloc? .406 E7E. Now, and of course we need to add this back. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So what we're doing there is basically, because these are base 64 number, or 64-bit numbers, it is the same to add a number or subtract that plus 100,000. So basically we're just calculating it a little bit differently. It should work now. So this should be $20i. If we dump this, what I expect to see is that looks like what I want to see. So if we get rid of line 29 here, we get a shell. So what is this ROP chain doing? So I know for the past 20 minutes or so, I'm kind of impressed that people actually, sat through me kind of rambling on as I was doing that. But what we're doing here is we're taking one gadget, which is a move EAX EDX pop 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 ret, and we're using that to load RCX. Even though the pop isn't doing that, the pointer that we're overwriting, or something that we're overwriting in this process, is going to get loaded into RCX. So we need to use that. And we need to populate RAX with a writable value, which EDX points at something it can write to. So basically, we're using that gadget for two purposes, both to load EAX and to make sure the RCX is at the right offset on the stack. The next gadget then is going to do a pop RDI, which reads a quad word off the stack, puts it into RDI, and then we're going to return. So we're going to take, this is the address of that gadget, and then this is the value we want to load into RDI. And then finally, we're going to use this gadget. We're going to add ECX, which we controlled because of this right here. We're going to add it to whatever RDI points at. And in this case, we've set up RDI to point into GOT, where the GOT entry for malloc is. So that entry points into libc, wherever libc is in memory, and says, when you go to call malloc, here's where you should be calling it. And so we're going to add to that this value to remap malloc to this bespoke gadget, that whenever we can get program control to this gadget, it'll pop a shell for us if certain constraints are met. In this case, the constraints are met because we can control them to some degree. Basically, this version of it, like this specific gadget, requires RSP plus 30 to be either null or look like an argv, which is a list of car stars. And then this right here, the add dword RAX EAX, was the reason why we needed to load EAX up here. That's it. It's a relatively simple ROP chain, because unfortunately there weren't a lot of gadgets to do it. But yeah, that's about it. We finally have popping a shell with ROP gadget, or I'm sorry, pdfcrack. It has taken us many weeks to get this far, but it works. We have landed a exploit. We've landed an exploit against a real vulnerability in a real piece of software that, as far as I'm aware, nobody wrote with the intention of it having vulnerabilities. I think probably over this weekend or the next couple weeks, I'm going to try and take all these videos. So we have several, I think we have over 8 hours of video now of going through and finding this bug and landing it and all of that. So I'm going to go through and I'm going to simplify it a little bit. As far as people who are watching, one thing that is very much worth noting here is that after all the work we went to, setting up AFL, getting it to work, running through with address sanitizers, triaging all of those results, doing all that heap grooming, it turns out we didn't have to do any of that, because there was a bug that AFL did not stumble across, which was just smashing the stack and letting us run a ROP chain. So I'm going to post on Twitter if people have feedback about it, because we're out of time for this week. But we could do one more week of pdfcrack. I'm at least somewhat against that. It is a little disappointing that the bug that we found and that we've been working on, we didn't actually land. But we do have a working exploit now, so I'm good with moving on to something else. And the next target we're going to look at is NumPy. And the idea would be to find new exploit, like write a fuzzer for NumPy to actually find bugs in NumPy and take a look at that. So if people have feedback about that, please message me on Twitter. And yeah, other than that, I will see people on Monday. I'm trying to think if there's anything else that I should mention before I get off for the evening. I think that's about it. Again, like normal, if you have questions or comments, feel free to message me on Twitter, leave a comment, message me on one of the many Slacks. You saw Slack and Discord messages pop up while we were talking. I also have IRC open here, so questions or comments, feel free to let me know. Other than that, I will see everybody on Monday. Not quite sure what we'll be doing on Monday yet, because there's no CTFs this weekend. I plan on spending this weekend basically rebuilding a lot of my computer, getting VMs set back up, things like that. Um, I'm not quite sure what we're going to do on Monday yet, but we'll do something. I think it might be uh, working more with some of the automated exploitation stuff, but we'll see where we get to. So, thanks everybody for tuning in, and I will see you all later. Bye.